Yes, let us find the inverse of this matrix A. Here the matrix A is given 1 minus 1 2 3. It is 2 by 2 matrix and we have to find its inverse. Now see, it must be a non-singular matrix. So let us check the determinant of A. Determinant of A is 3, 1 into 3, 3 minus 2 into minus 1. That is minus 2. Okay, so its determinant is 5 not equal to 0. Hence this matrix is non-singular matrix and the inverse exists. So whenever you have to find the inverse of the matrix, you must check its determinant. If it is equal to 0, sometimes it may be equal to 0, and if it is equal to 0, the inverse doesn't exist. So here we get it is determinant of the matrix as 5, so inverse exists. A into A inverse is equals to, I'll write the relation and substitute the matrices. Matrix A here into A inverse is equals to, right hand side matrix will be the identity matrix of order 2. Okay, now we have to convert this matrix A in identity matrix, that is 1 0 0 and 1. Okay, so we will convert this matrix into identity matrix using row transformation. Okay, so here there is 1, we want 1, it is there, so we will change the another element, and when we use this row transformation, then at that time we have to convert the matrix column wise in the identity matrix. Okay, so first row transformation here will be, this is 2 and we want 0 here, in place of 2 we need 0. So 2 minus 2 will be 0. We will subtract 2 from this 2, but we'll multiply the first row by 2 and then subtract that 2 from the second row element. We are changing R2, we are changing second row element, so there will be the change in the second row. Write the first row as it is. Okay, so in the next step you are going to write the first row as it is. This is 1, this is minus 1, will write as it is. On right hand side also 1 and 0 will remain as it is. Only the change we are doing in this element of the second row. So R2 changes to R2 minus 2R1. This is R2 element, 2 minus 2 into 1. Here I am writing 2 minus 2 into 1. Okay, so we get this element 2 minus 2 into 1. It will become 0. First element 0. Second element is 3 minus 2 into minus 1. So this is our second element, 3 minus 2 into minus 1. And now it becomes 3 plus 2, 5. So here it is 5. On the same way, the same row transformation will do on the right hand side. On here we get 0 minus 2 into 1, it becomes minus 2. 1 minus 2 into 0 will be 1 only. So we get 0 in this place, 1 and then 0. Now our task is to make this 5 as 1. So here to make this 5 as 1, directly we will divide by the number 5 to the second row elements. So now R2 changes to R2 divided by 5. Now we will divide this second row by 5. So we get 1 minus 1. There is no need to change the elements of the first row. First row will remain same. And the second row is 0 divided by 5 will be 0. 5 divided by 5, 1. On right hand side it is minus 2 by 5 and 1 by 5. Now these terms are in fraction, so be careful while calculation. And next step, now here we get 1. Now in this place a 1 2 we need 0. Instead of minus 1 we need 0. This is minus 1. Okay, so we will add this minus 1 to this one which is in R2. Okay, and then in the we get the 0. So R2, this R1 changes to R1 plus R2, because now we are doing the change in the first row element. So here we have to write R1 changes to R1 plus R2. R1 changes to R1 plus R2. So this is 1 plus 0. This will remain 1. Minus 1 plus 1. It will become 0. On the right hand side, this is 1 minus 2 by 5. So here we get the element 1 minus 2 by 5. Solve this carefully. It is in fraction. It is 5 minus 2 by 5. So here we get 5 minus 2 by 5, and hence it is 3 by 2. Okay. So sorry, it is 3 by 5. So 3 by 5, then 1 by 5, 0 minus 1 by 5, 1 by 5, minus 2 by 5, and 1 by 5 will remain as it is. Okay, so A inverse of this matrix, we can take 1 by 5 common because each element has 1 by 5. So 1 by 5 is common, and hence this matrix is 3, 1, minus 2, 1. Okay, so inverse of this matrix is 1 by 5 into 3, 1, minus 2, 1. In this way we get the inverse. Now this left hand side becomes identity matrix. I into A inverse is A inverse. Okay, and in this way we can find the inverse of the matrix.